Hello everyone, welcome back to Engineering Space, where engineer breaks the border of engineering. Today's video is about the continuation of the previous videos regarding to designing and analyzing simple tower steel frame design using SAP 2000 by Computers and Structures Incorporated. So in the previous videos, you may check the link below in the description or through the button on the corner of this video. We just finished modeling the structure, and then we just finished modeling the steel frame design, and now we're going to continue to start analyzing it using SAP 2000. And in the previous video also we have done with response spectrum variables, and now we're going through to find some materials on it. So this is how our structures looks like. Yeah, and then after we defining the response spectrum, so in this section, I saw in here we're using response spectrum in Jakarta, where exactly the project gonna taking place, and then where we're using the standardization of Indonesian use here. Let me just press OK here. So what we need also after we defining the response spectrum here, as you saw here in the previous video, we just defined the response spectrum. And just wait a minute. Alright, this is the response spectrum that we're gonna use in this analysis. If you not understand more about what is response spectrum means and what these variables mean, you may check on the other video by one of videos that completely defining what response spectrum analysis is. You may check it on the below video description or through the corner of this video's button on the corner of this video. So definitely we're gonna use the response spectrum in Jakarta, where our project gonna be taking place, and of course we're gonna use the response spectrum and another variables regarding our structural analysis using Indonesian code that they called as SNI, or Standard National Indonesia. So what after that is, once again, that so after we define the response spectrum that I explained through to you previously, the other part that we need to define is the load patterns. But by the way, if you don't too familiar with what response spectrum means and what the variables means on this section, like let me show you again the variables contains in the response spectrum. So if you don't too familiar with what is spectral accelerator and another parts of this section, you may I refer you to go to one of the videos that I think interesting and give the comprehensive explanation about what response spectrum means. You may go through the description below, the link in the description below, or simply put the button on the corner of this video on the upper bottom link that we provide for you. So okay, let's be back to our project again. Once again, what we need to define is the next is the load patterns. Load patterns mean what case of load that we're gonna do or we're gonna give to our object geometry or our structural design. So basically I will give you the simple load pattern, and this was meet with Indonesian load standard. So I will start with date load, is the first with self like multiplier equal to ones, and then it's also contained with self date load with which will be equal to 1 again, and then after that it is live load where we can put here live load equal to 1 again. Oh, sorry, for self dead load I think we need to modify it to 0.5 maybe. Simply put modify, and then after live load we also need to define the wind x, which will be the type equal to 1, and then it should be self multiplied by 1, and then we use, because Indonesian standard not contained in this section, so I think we need to put the other load pattern that was automatically generated. So I think it will be equal to it as key in this case. I think it doesn't matter. Later we're gonna try to redefine some that maybe not similar with Indonesian standard. So I put 8 here, and then sorry, it's not B because we're gonna use AC716. I think it will be automatically generated between every section for X translation, Y translation, and even maybe for Z translation. So let me modify it once again, and then after that I will put the rain, because Indonesia is one of country that is tropical, so we need to also define it as so yeah, because rain, I think it will be equal to snow in the maybe some countries in Europe or in United States, right? And we put the self multiplier again by 1, and add new load pattern, and after that we add again the earthquake. So this is basically the earthquake translation with X, and then it should be quick here, and then let we use maybe SK716. I think not quite similar with us, not in Indonesia. I think UBC will be more interesting to be used, or yeah, IBC. I think it's quite similar also, but yeah, let we use universals like this one, the 7, and add the new load pattern, and one else for this one. Modify it. So yeah, so I think it was enough with this pattern. We have now 1 2 3 4 5 6 7 load patterns, and then I think it was enough, and it was covered everything about structural analysis so far. So just press OK, don't forget to save it again. And after we define the load pattern, what we need is also the load cases between every case that we defined previously. But one important thing that you need to consider is the earthquake pattern that you must modify it. So I put here modify, and then put here the load case static should be response spectrum, and then yeah, let it define it default, and then just add the scale factor into 1. So I think it was enough here, and then also the earthquake translation to Y it's also need to be defined as response spectrum load case with accelerator equal to 1. Press OK again, and then equals. So yeah, so far we just defined two variable, the turn patterns and load cases. So one of the most important thing also is the load combination. So load combination means that how we combine every load in our geometry, in our design, from dead load, self-dead load to live load and rain load, and even further. And it could be combined by every pattern of load. And to do this, you need to back to the code that you use to analyzing the structure. For this time, because we use Indonesian standard, so we're gonna refer to Indonesian standard for load combination. Let me show you the load combination by Indonesian code. So here is it. Is the load combination by Indonesian standard so far. So we're gonna use this combination. Let me just put here add new combination and then use combination 1. So we put that load here equal to 1.4 and press OK. Combination number 2. Just wait a minute. Okay, sorry. So I think it will be better if I put it here. So the second combination should be 1.2 dead load with 1.6 live load and 0.5 for rain load. So yeah, let's be back to here. Combination number 2 is equal to dead load with scale factors equal to 1.2 and press add here. And for the live load with scale factor and 1.4 and the rain load which will equal to 0.5 and then press OK. And after that we add new combination again. Combination number 3. So be dead load again with scale factor equal to 1.2 and then rain load which will be equal to 1.4 and the live load which will be equal to 1 and then press OK again. So after that we add new combination number 4 which will be dead load again which contain 1.2 scale vector numbers and then live load which will equal to 1 and then rain load which will equal to 0 which will equal to 0.5 and then after that wind load which will equal to 1 scale factor and then press OK again. We go to the combination number 5 which contain the dead load with scale factor equal to 1.2 and then live load which equal to 1, and then earthquake with translation X, which will equal to 0.5, and earthquake translation Y, which will equal also 0.5. So this is combination number 5. We're going to combination number 6. Which will contain dead load with scale factor 0.9, and then the wind load, which will equal to 1, and then yeah, this is the combination number 6. So this is the last combination number 7, which will contain dead load with scale factor 0.9, earthquake with translation X, which equal to 0.5, and earthquake translation Y, earthquake translation Y equal to 0.5, and then hit OK. So yeah, this is the load combination based on Indonesian code standard, but definitely we can also add default design combos. But before that, let me just push or press OK here, and let me first save it. And after that, I think we need to load auto load combination by default of the standard. So let me default here and just still frame design. So we got the addition of load combination, which contain 18.1 plus 7, so it will be equal to 88 load combination. So I think it will be enough and give us full configuration for every model of load combination. So let me press save again. So after that, all we need now we just set up, start from the geometry itself, and then after that the plan view from the X and Y translation. And before we hit run analysis, one of the more important thing is to set the join or to assign the join on our model. So so let me go to the bottom of our model. So this is the 0 plan, or it will equal to the base or the bottom of our structure, which if I click on this and you got a point here, or if I go to here, you get a point here. So we need to define here the join of our structure. So let me just block it and assign, go to join and go to restraint, and then we put the fixed restraint in join local direction. So let me just press OK, and then it transformed. So now I think we all set up, because everything that we need to define was considered. Let me check it first, frame section. So all we need just to run analysis. This is the notification that's shown once you press the star. When you want to run analysis, simply go to this, or go to analyze and run analysis, or simply press F5 on your keyboard. on the Windows keyboard, of course. Yes, because so far computers and structures application not support in macOS, sadly. Yeah, so let me go to analyze again, like what I said to you, and then run analysis. Notification shown that what kind of case that you're gonna be run or not run, right? If you want to consider, maybe you don't want to run the analysis for wine 2 and wine 3, so simply just run or do not run keys. But for this time you're gonna define everything. Oh yeah, I just forget it that we just don't put the load here. Oh yeah, I forget, we just put the load here. Let me assure this one. Let me go to assign load, grab the load, okay, and then we replace the existing UZ, which will be equal to maybe 10 kilonewton per 1000 liters. So it will be defined. Let me give you some example to become more familiar with this. If I put maybe here each, yeah, the number will be changed. So all of these loads will be distributed later. So let me just press OK here. So right now we just get ready to analyzing it, so all you need just to run the analysis. But before that, let me back to here. We need to the standard view, then just press play here. So after that, let me press here run. So it will be start to analyzing it, and then all we need just to wait until we got a result. And yeah, this is the result of our frame. If you want to see how the animation looks like, just press their animation here, and this how the behavior of the shape of the geometry gonna be looks like in the deformed shape. If I go through here, and you're gonna see how it's look like in the self-deadload model. Go again, you gonna see how the geometry looks like in the live mode. And yeah, let me just stop animation here. And one of the more important thing, we want to analyzing a structure, or in this case we're gonna designing the steel frame design. We also need to define not only the material that I previously tell to the frame section using in L shape or angle shape with 50 by 50, but we need to also, because there's some part that are go far from the what I mean, like the stress maybe gonna be over stress on or not, and this is very important for us to designing it with to meet the standard requirements. So to do that, simply you can go to design, and we have 1 2 3 4 options here. And because we use steel frame design, so we go to steel frame design. We're gonna learn more later, and maybe in other videos about concrete frame design, aluminum frame design later. But we go to steel frame design here, and we're gonna start design and check the structure, does it overstructure or not. So just press it here, and then it will start analyzing. And yeah, so we're gonna get the best result here. And then almost done. You're gonna have the option here with L shape or angle shape with models, and here is 89 times 89, and this is the auto select frame from what we have previously defined by defining the property. If you see in the previous videos, in the first video, maybe you're gonna see that how we define the angle shape with section equal to 15 times 15, but I just add also several option of angle shape from 51 into 102 model L shape, right? So I think it's enough for now. So I will just create the report. If you want to see the report or want to see the table and how the, maybe we go to joint analysis and sector report, and then base reaction here, and then joint reaction maybe, yeah. And of course we need also the design data, but I think because we wanted to see the result of design, so I think I want to checklist on this one and then press OK. So it will be automatically generate the design frame, design forces here, and then for beams and for braces, and then for columns. So this is the result of design forces for columns. Let me just down here and then scan. Think done it to this one. I just wanted to see the steel frames. Yeah, as you can see here, the maximum model that was generated is with angle shape 51 times 51 times 3.2 with statistics is now messages, so we can conclude that the design will be met if you can, and it will be safe if you use this type of L shape or angle shape with numbers or with the design is equal to 51 times 51 angle shape. So yeah, I think that's enough for me. So we may change the other section on this frame by angle shape 51 and times 51. So I think that's all for now. Thank you for your attention, and as gift from us, we're gonna create report for you on this model, and we're gonna give you what else, the RTF file and also the geometry design of this file. So that's all from me for now. Thank you for watching this video and hope you enjoy it. If you like, don't forget to share it, and then see you again on the other videos of engineering space about anything regarding infrastructure or engineering. Thank you. Assalamualaikum warahmatullahi wabarakatuh.